Yesterday we talked about finding a recursive sequence for a list of numbers. In this case, the rule appears to be add 2. Just to confirm, we make sure that it works for a few numbers in a row. This appears to have a recursive rule of start with the first number being 3, and to find any particular term, we're going to take our previous number, whatever that is, and add 3 to it. This is called the recursive rule. It requires you to find one number at a time. But this is a special type of a sequence. When you have a sequence where there's a rule specifically where you just add the same number over and over again, it's called arithmetic. Like arithmetic. What it means is that there's a constant increase of a specific value, and that is called the common difference. So the common difference which can be positive or negative, in this case is D, is going to be equal to an minus an minus 1, meaning if you take any term in this sequence, like 9, and subtract the number that comes before it, you'll see that the change in those two numbers is 2. If I picked 3 and 5, the change in those two numbers was 2. So the common difference in this case is 2. And the reason this is useful, or it's important to have this as a distinct type of a sequence, is because if you're asked to find a particular number in the sequence, it could be a pain to go one number at a time. So if I asked you to find the 150th number in the sequence, that shouldn't be as hard as it might be using a recursive sequence. But you would have to add, I wrote add 3, the rule was add 2, excuse me. So this is a mistake here, I apologize. So this should say plus 2, meaning to keep adding 2 to the previous number. But to find a 150th term shouldn't take that long. So what we're going to do is write what's called an explicit rule. An explicit rule is a rule that can be used to find any term in the sequence by just plugging in the term number. And the way we're going to do that for an arithmetic sequence is using this rule. An is equal to whatever our first number is in the sequence plus our common difference times n minus 1. In other words, if I want to find the 150th term in the sequence, I don't have to go one number at a time until I find the 149th number and then add 2. I can just start at 3 and I can add 2 149 times to find the 150th term. So the 150th term of this sequence will be equal to 3, and I would have added 2 149 times, which is 298. And after adding 3, we'll get that the 150th term of the sequence will be equal to 301. So this is the formula for an arithmetic sequence. Let's take a look at the other sequence we have here. This sequence is called the geometric sequence. It has a rule where you multiply by the same number over and over again. This number can be positive or negative, or bigger or smaller than 1. If it's smaller than 1, the number will be decreasing as you continue in the sequence. The rule appears to be times 3, just to confirm, using as many numbers as we're willing to do, but the rule does appear to be times 3. If we wanted to write the recursive rule for this sequence, it would be a1 is equal to 2, and the next term can be found by multiplying the previous term by 3. So if I wanted to find the next term here, I'd take 54 and multiply by 3, which would be 162. Now, geometric sequences can also be written in an explicit manner. Now, that 3 here is not called the common difference. It's known as a common ratio because we're multiplying. The way we find the common ratio, which is also known as R, is we take an and divide it by an minus 1. In other words, I take a later number and divide it by the number that comes before it. So 54 divided by 18 is 3. If I picked 162 and divided it by 154, I would get 3. If I took 18 and divided it by 6, I would get 3. If I took 6 and divided by 2, I would get 3. So the common ratio is just take the newest number and divide it by the number before it. So the formula for a geometric sequence is an can be found by taking the first number and multiplying it by whatever the common ratio is to the n minus 1 times. In other words, if I want to find the sixth term, so a6 will be equal to the first term having been multiplied by the common ratio. And this, by the way, in this case, the first term was 2, and we're going to be multiplying by 3, and we're going to be doing that 5 times to get the sixth term. All right, so if we do this, we will find that a6 is equal to 2 times 3 to the 5th should be 243. If we multiply that by 2, we should get a6 is equal to 486. And then I think I was one number away from getting that anyway. If we multiply the 162 by 3, that would be 300. And then 180, which is 480, and 6. So this would be 486. Normally for geometric sequences, you don't look for numbers as far down as you would for an arithmetic sequence because multiplying by 3 enough times will make a number incredibly large. So the following sequence, 6, 12, 24. My question to you is this an arithmetic sequence or a geometric sequence? And what is the common ratio or common difference of the sequence? And to find the value of the 10th term. Next, I would like you to determine if this sequence is arithmetic or geometric. Determine what the common difference or the common ratio is and find the measure of the 15th term. See you in class on